Hey, pre-calculus, I'm going to do my best to give you examples 4 and 5 as thoroughly as possible. But I'm going to keep moving along the lines of being able to graph logarithmic functions using their inverses, namely the exponential functions. This is part 2 of our 4.6 of our 4.6 series. Let's get to it. So what are the 3 defining characteristics of this logarithmic function that we need to take note of in order to graph this one properly? First one is right here. A negative on the outside of the log means that it has a vertical reflection. What does that look like for an exponential? Well, we already saw in a previous example that a vertical reflection for a log yields a horizontal reflection for the exponent. Okay, check that off the list. What about an x plus 1 inside the parentheses? That would be a shift left, okay? Left 1 unit. Well, here's the deal. If a vertical reflection became a horizontal reflection, that means a horizontal shift becomes a vertical shift. Left 1 for the log means down 1 for the exponential. Okay, see how that works? If vertical goes to horizontal with our reflections, then horizontal goes to vertical for our shifts. And then just the opposite happens. If the log is shifted up 1, which is a vertical shift, you are going to go to a horizontal shift of right 1. So what this does is it allows us now to build an exponential function. What does this exponential function look like? Well, good thing we talked about that last earlier in this chapter. It's got a base of 4 for the log, so it's got a base of 4 for its exponential. It's got a horizontal reflection, which means you're going negative x. It's going to go down 1, which means you subtract 1 from the whole thing. And it's going to go right 1, which means we've got this structure inside of our exponential. So, to graph the log, you can plot all the points that make this thing a real thing. So let's go ahead and do that first. I'm going to give us some room here. Our standard XY table is going to be -2, -1, 0, 1, 2. I created some space though because usually when we have a horizontal reflection and, a horizontal shift, you're going to move these points around. So, the horizontal reflection is supposed to negate everything, so technically this becomes +2, this becomes +1, this becomes 0, still 0, -1, -2. Doesn't seem to change all that much, right? It just reversed the order, but you would do that first and then you would add 1. So add 1, add 1, add 1, add 1, add 1. So the x coordinates that give you a more legit value for the points that are on this are going to be x equals 3, x equals 2, x equals 1, x equals 0, and x equals -1. It's kind of giving us a reverse order of things. So then we could go to our table, and we could do this in a regular calculator that has a table, or just plug the numbers in really quick. So if I plug in 3, I get 3 minus 1, which is 2, 4 to the -2 power, which is 1/16. 1/16 minus 1 is -15/16. And then if you plug in 2, 2 minus 1 is 1. 4 to the -1 is 1/4. 1/4 minus 1 is -3/4. All right, this will be 4 to the -1 minus 1. That'd be 4 to the -0, which is 4 to the 0. 4 to the 0 is 1. 1 minus 1 is 0. And after that, 0 minus 1 is negative 1. The negative of negative 1 is 1. 4 to the 1 minus 1 is 3. And then when you plug in negative 1, you start to get really big numbers there. Sorry, I went through that super fast. My apologies. If you have a calculator with a table, you can plug this into the table and go to town, okay? Now this is kind of tricky because 15 is a really hard number to kind of quantify on this small grid. Just keep in mind that if this is the table for the exponential, the table for the log literally flips everything around. So now the log table, and maybe I wasn't clear on this on the first video, the log table is now every y value becomes the x value. So you're plugging in negative 15/16, and you're getting out of that 3. You're going left almost 1 unit, and then plotting the point 1, 2, 3. Then you're plugging in negative 3/4, and you're getting 2. So that's like negative 0.75. Yeah. You plug in 0 now. It's no longer the y coordinate but the x, and you get 1 out of that. So 0, 1 is a point on there. And then you've got 3 now is my x coordinate. 3 corresponds to 0, 1, 2, 3. And then 15 corresponds to negative 1. Suffice it to say it takes a long time to get all the way down to negative 1. So what you could do is you could say it's ever so slightly moving downward. Okay? So if it's ever so slightly moving downward, we want to make this a very gradual curve. Oh, I'm not very good at this. All right, so that's what we got. Now the question is there anything going on left of that point right there? And the answer is, yeah, there is some stuff. If you recall, logs cannot go left of a certain point. And in this case, you can go back to the log and say, this was a normal log whose y-axis is generally going to be the cutting off point, but since it's got a plus 3 inside, that would shift that cutting off point left 1 unit. There's kind of like an asymptote here. And then it gets infinitely closer to that as your x coordinates approach negative 1. Like if I went in this calculator and I tried to plot, negative 0.9999999, we are approaching an infinite value. It's going to be a really big number if we plug that number into this right here. So kind of complicated, but hopefully you guys followed my steps for how we got this. Okay? And then how we chose these as the more appropriate x coordinates to plot so that it would actually give us legitimate values. Let's see if we can make sense of this in number 5. All right, so number 5, let's determine what the corresponding exponential function would be. Well, we know it's got a base of 3 for sure. You got to factor this negative out, otherwise it won't lead you in the right direction. Okay? Just make sure you guys are keeping track of that, otherwise your exponential function will be off, and it'll be a cascade of mistakes from there. So the negative on the inside means the log has a horizontal reflection. If the log has a horizontal reflection, then the exponent has a vertical reflection. So the vertical reflection is outside of the power, outside of the base. Write 3 for the log. Is the same as saying you have a horizontal shift. I'm sorry, not write 3, write 1. You have a horizontal shift, which corresponds in the exponential as a vertical shift of 1 unit up. Right means up. Think of it in terms of positive. Positive, right. Positive, up. Positive direction, right. Positive direction, up. And then if the log has a shift down 1 unit, sorry, down 2. I keep saying the wrong number. The unfortunate effects of old age. So exponentially, if it's down 2 for the log, you're going now left 2 for the exponential. Left 2. Down means negative, left means negative. Right means positive, up means positive. So if we can plot the points for this, then we can plot the points reversed for that. So let's get to it. The XY table for our exponential is going to be, well, it normally is going to be -2, -1, 0, 1, 2. But since it shifted left 2, we're going to take 2 away from each of these. So -2, -2, -2, -2, -2. That negative vertical reflection does not change the horizontal at all. All right, now we can plug these values into that. But you know what? If we want to use our table function, there is absolutely no shame in doing so. We can clear that out. Plug in -3 caret. Make sure you put grouping symbols around the x plus 2. Otherwise, you're just not going to get the right points. The table gives us, at -4, 8/9. -3, 2/3. -2, 0. -1, -2, 0. -8. All right, so hopefully we're seeing the picture here. These are inverses of one another, so the y values become the x values become the y values, and everything gets flip-flopped. All right, so -8, 0 is a point. That's a long way away. -2, -1. 0, -2. 2/3, -3. 8/9, -4. All right, so I guess the question is, do we understand what pattern is happening here? Did I forget to plot one? No, I got them all. So the pattern. We always have like a brick wall where the log does not go beyond that. If it's a horizontal reflection and a shift right 1 unit, what you can expect to see is an asymptote at 1. It shifted it right 1 unit. All that makes sense. And then the horizontal reflection, instead of coming up this way, it's going to move up that way. So this is what's happening. You're getting ever closer to that asymptote, but never crossing. And then you're just gradually moving upward from there. Yeah. All right. Now, I'm going to do this one last time. I want to graph this one just so that we get the visual for what's really going on here as our logarithm relates to the exponential. So if I were to graph just the regular exponential, here's what I'm getting. 0, -8. -1, -2. -2, 0. -3, 2/3. -4, 8/9. This means we have a horizontal asymptote at 1. This means it's shifted left 2. Well, we already plotted the point, so that's not going to be a big deal. This is a vertical reflection, which means it's shoved underneath the asymptote. So it's never going to go above the asymptote. Now here's the visual cue. Everybody should be reflecting over this green line perfectly. Now can you guys see how the points partner with one another? They're all equidistant to that green line from one another. So that's the last. I think that can do it. If you guys have questions, please just email me. And you know what? I think I'm just going to stay away from that alternate explanation that crashed and burned when I tried to do it on that Zoom meeting. I just feel like this is so much richer in giving us a complete understanding of how exponentials and logs work together. The other version of that is just kind of like, can you plot points in a calculator? And I just don't think that that's a huge skill that we need to really focus on. This is like brain cuisine with all the nutrients. The stuff I was trying to show you guys on the video or on the Zoom was like junk food. All right, this metaphor is starting to drag on a little bit too much, so I'm going to stop. Thanks for watching.